All right, guys. Mr. Collins here. So what you are seeing is a multiple part final review video study guide slash key. So if you are not part of my class, or not familiar with this process, the way I usually do this, so I'll go through every question. I'll kind of talk and narrate about what I think needs to be kind of said and need to be perceived about the problem so you can understand it. And of course, you'll see all the work necessary to find the answer too. So like I said, I'm going to try to be doing this in multiple parts. I'll probably try to do this probably in 10 parts because there are 10 pages to this. But in the end, you're here because you're trying to get better. We appreciate it. So let's go. Let's start this. So first question: Coach Hancock is standing on an oak tree, and uh, Coach Hancock, who's that guy right there, is 64 inches tall. The tree casts a shadow 900 inches long, and Coach Hancock casts a shadow 96 inches long. Use information to find the height of a tree. Okay, first of all, we have to go ahead and establish one important fact, which is you're looking at a similar system. So what we have here is a couple triangles. Here's triangle one. Oh, that's terrible. Let's try it again. Here's triangle one. Here's triangle two. And those triangles are similar. Now, if we want to dig a little deeper into how we know that, it's going to be pretty straightforward and simple. First thing, we have an angle here that's right because trees and people are going to try to stand upright. That's their natural position, so that should be perpendicular. And the sun, its rays will cast a congruent angle in terms of its shadow. And so we do have angle-angle similarity. Therefore, all the stuff we're going to use with similarity should be valid. So next thing we have to do is to get some numbers into this problem. Luckily, everything they gave us was in inches, so we don't have to even kind of consider like whether or not the units have to match really well. Let's just start importing numbers. So Coach Hancock is 64 inches tall. So let's go ahead and get his height in here at 64 inches. The tree casts a shadow 900 inches long. So getting back in here, we have a 900-inch shadow. Coach Hancock casts a shadow that is 96 inches long. So again, let's get that in here as well. Okay, so here's 96 inches from there to there. And we use this information to find the height of the tree. Let's go ahead and mark that as well. So we're trying to find x. So the first thing we have to do is to, one, now that we know that this is going to be a similar triangle kind of problem, we know that the proportions are in play. The definition of similarity is that the side lengths are in proportion to one another. So what I would suggest to do first is to maybe write out a literal equation. So instead of jumping right into the numbers, let's like write out the pieces. What I mean is this. Let's take the red triangle and realize that we have like a left side and a bottom. And let's write that into a ratio. So like the left side of the big triangle is to the bottom of the big triangle or the base. And so when you try to match that with a small triangle, we should have the same order. And so the left side of the small triangle should be the same thing as the bottom of the small triangle. So like this is just going to help us like visualize our proportion. It might be in a while since you did any proportion work, so this is going to be a good step for us. This shows us that everything is indeed is aligned correctly because we have uh, little bottom, and then on the left hand side we have just the stuff for the big triangle, and then on the right hand stuff just the stuff for the small triangle. And so we can have confidence that our proportions are going to be set up really well. Now we can go ahead and insert those numbers. So the left side of the big triangle is x. Okay, so left side of the big triangle is x. The bottom of the big triangle is 900. And that should be equal to the left side of the small triangle, which is 64, and the bottom of the big triangle, which is, I'm sorry, bottom of the small triangle, which is 96. Now from here, you can kind of pick your favorite mathematical solving method. I'm just going to use cross multiplication because I'm comfortable with it and I have a calculator handy. Okay, so we have multiplication this away, which will give us that 96x. And then we have multiplication that away. So 900 times 64 is 57,600. Now we're just into algebraic solving. So to get x by itself, we'll divide both sides by 96. Which would give x a height of 600 inches. Now, we don't want to leave it at that. We probably want to take a second just to see if that even makes sense, given the context of our problem. And we don't have to even do any hard calculations to figure that out. We can just take a look at this. If you look at Coach Hancock, the little guy here, he's 64, his shadow's 96. So although we're not trying to say like if there's a ratio here we should be looking at, we can see that he's definitely shorter than his shadow, and he's about the shadow's about what the ratio is about 2/3. And so if we look at the number we got here, 600 for the height of x, that matches because again the overall height is less than the shadow, and if you look at 600 of 900 again, that's approximately 2/3. And so like that's a reasonable answer. Let's go ahead and move on. Let's see. If two shapes are similar, all their angles are. Well, we talked about this earlier. The reason we were able to do this at all is because these triangles were similar. We actually use angle-angle similarity, which indicates that all angles of similar triangles are congruent. Okay. And all the sides have the same, well, we talked about this too, should have the same ratio. All right, what are the three shortcuts for similarity? In the end, what they're saying is like you could show every single set of sides have the same ratio and all the angles are congruent for all triangles, but there are some shortcuts we can use. The big one that we use probably the most geometrically is angle-angle, but also if you show all three sides are in proportion, or you have a side angle side in a row that are in proportion, you are good to go. And now remember, this is congruency, this is proportionality. So we're talking that they have the same multiplication factor, same scaling factor, dilation. So we can use that information below to see if these are similar. Now we're going to be talking purely shortcut stuff here, guys. So what we're looking for is one of these conditions to match in both triangles. Let's see what we have here. Well, right away before we can do anything else, I see that we have with this we have some sides here, and we have some sides here. Now they do correspond. So like you can say like this guy corresponds to that guy in the same way this 16 corresponds to that 40. At this point, even though we can note that there's going to be a vertical angle right in the middle, we can actually say definitively that these are not similar. Okay? And the reason why they're not similar is just based on the side lengths we've been given. So this does look like it could match SAS, but the problem here ultimately is the ratios aren't the same. So if I take like 16 over 39, that is not the same as 16 over 40. The multiplication factor isn't the same going from 16 to 39 and 16 to 40. So even though they do share that angle in the middle, that's actually meaningless in this problem. These guys are not similar. All right, so for this guy, it looks like we don't have any angles, so so our only hope is of meeting a side proportionality. So what we have to do is actually crunch some hard data here, get some numbers. We also have to kind of figure out which side goes with which side. Now, if you're kind of looking, and we do have to assume this is to scale at least, looks like we have the GF matching with the CB. I would say HG matches with AB, and then AC and HF. So the reason we're identifying that right off the bat is because it gives us something to actually start testing. And so if this was similar, all these proportions would be the same. So we could say 14 over 84 has to match 12 over 72. Has to match, I don't know a color for this. Let's use yellow, whatever. Has to match 8 over 48. Okay. Now, looking at those just off the bat, it's kind of hard to tell whether or not they do, just because the numbers aren't, let's say, the nicest numbers in the world, but we can actually test these by turning them into decimals. So we have 14 divided by 84. That's approximately 0.17. And we can test that for the middle one. We have 12 divided by 72. Okay, so that's approximately 0.17. Now the number I'm actually getting is 0.16 repeating, and that was for both of them. Let's try this last one, 8 divided by 48. Lo and behold, this ratio is again about 0.17, and it's exactly 0.16 repeating. So we actually say yes to this one. Okay, so this one is yes, because it's going to meet side, side, side triangle similarity. And again, it's not congruent, it's not supposed to be the same numbers, but they do have the same ratio value, which means all the sides scale the same. Another way to say that, um, if you took 72, if you took 72 and then multiplied by 0.16 repeating, you get 12. Same thing with 84. If you take 84 multiplied by 0.16 repeating, you get 14, and 48 times that 0.16 repeating, you get 8. So we do see like this scales. In this case, it's a reduction because the number is smaller. We do see it actually scales correctly, and so therefore they're similar. This one we have no numbers, so what we have to do is try to find either, well, we could even find sine angle side. So what we are hope is that it's going to match angle angle, which it does, because you have this angle right here. You see it marked with a single arc marking. That indicates that it's congruent to J, and then you have U that's congruent to K. And so yes, this does meet angle angle similarity, because angle T is congruent to angle J, and angle U is congruent to angle K. So we have our first page here. Well, yeah. Let's go ahead and stop our first page here. That's been going for a while. So we start off with a very nice little typical, I would say even, similarity problem, in which we have to set up a proportion. After proving similarity, set up a proportion and solve. Then we had some facts about what it means to be similar, the shortcuts for similarity, and then some application actually testing those conditions out. So that's the video 1, guys. I'll see you in a moment in video 2.